Okay, the final thing that we're going to talk about today is just the notion of a complete graph. And it's the final thing, so complete graphs are going to complete the lesson for today. Awesome. And that's going to be covered under, in this case I wrote it just by itself as learning objective E. All right? And the definition of a complete graph is just going to be, whatever the vertices are. Right, that notion has remained the same all throughout the lesson. And in this case, the edges are going to be defined in a very special way, which is just the fact that every single possible pair of vertices that you can have in the graph are there. So in other words, UV is an edge if U and V are both part of the vertices. Right? The way that this is often going to be written is as K sub n, which I wrote at the top of the board. So n represents the size of the number of vertices, and the K just means complete, because that's how we spell complete nowadays, I guess. That's what the cool kids are doing. Cool, also with a K. And a little example that I have up here, my little friendship graph on Facebook has been expanding because, remember, I'm Star, and Star made friends with Kat a long, long time ago. And recently we made a new friend, and Bird is our new friend, right? And Bird meets both of us at a party, so we all get to be friends, and he makes friend requests with both of us, and we both accept. And so now we're like forming a little triangle, which I talked about earlier when I talked about a cycle. This is a 3-cycle, but it also happens to be K3. This is K3 because it is a complete graph on 3 vertices. So that's cool. All right, well, your little friendship graph can continue to grow. Let's say that we meet, I guess, like Happy Anime Girl. There's only like so many cartoon things I can draw. And we meet her at yet another party, and she decides to be friends with all of us as well. So she makes all those friend requests, and so we all end up having edges with her. All right, and as you can see now, is we have a K4. All right, and I kind of feel like drawing a K5. I have to think of like a new monstrosity or cartoon friend to draw. It looks like a cupcake. I hope that looks like a cupcake. So we meet Cupcake at some other party. I guess these guys go to a lot of parties. But anyways, we all end up becoming friends. Okay? And so now this is a nice little K5, which I think is also a Moore graph. If you want to look that up later on. And so this is a complete graph. So certain things that you'll notice about a complete graph is if you look at the number of neighbors for each vertex, in this case we all have 4 neighbors because the number of neighbors that everyone is going to have is going to be just the number of vertices minus 1 because we're friends with everyone else except for yourself. All right, so let's go back to learning objective B, and we talked about the degree. Well, we know everyone's degree because it's just n minus 1, and as it's going to turn out, there's n of us, so if you do the sum of the degrees, well, there's n vertices. We all have the same degrees, so it actually turns out to be n times n minus 1, which means the number of edges is n times n minus 1 divided by 2. And fancily enough, this is a nice thing, is it turns out to be n choose 2, which makes sense. For everything in this set, let's pick out every possible pair. Well, there's n choose 2 ways of doing that. So that's going to turn out to be the number of edges within that complete graph as well. All right. So just to wrap up, we've talked about a bunch of definitions: graph, subgraph, digraph under learning objective A, degree and neighbor under learning objective B, C, connectedness, reachability, and connected components. D, path, closed, cycle, and length, as well as simple. And then finally, we talked about complete graphs. Right, so those are all the definitions that we went over today. You should know what all those words mean, and you should also understand how they would work together. So what would it mean to have a clique, or in other words, like a connected, a complete subgraph of a particular graph? All right, and that's what I'm going to leave you off with for today. I don't know, something, something, sign off, something, something, the end.